makeup lecture. So we've been talking about population proportions, and I just want last little subject. This will just take about 10 minutes. I want to talk about confidence intervals for population proportions. So remember, this is now our test statistic. So our test statistic z, but you'll remember that I defined p hat as equal to x over n. So what I'm going to do is I'm going to divide both the top and the bottom of this equation by n. And I'm going to skip a step, and I'm going to hope you can see what happened with the algebra. This means that this is the same as p hat minus p over p 1 minus p over n. So remember, the point of a confidence interval is I'm trying to find if that is this represents my proportion that I trust that this p hat, that the true p hat is somewhere in this domain between these bounds. So my confidence interval I'm going to say mathematically, if I call this negative ZA, as I've been calling it in class, and ZA, as I've been calling it in class, the book calls this Z alpha over 2 and negative Z alpha over 2. Then I can describe my confidence interval mathematically by saying P, this is probability, so this is capital P. That my true Z is between these values is approximately 1 minus alpha. Now this Z I just defined here. So I'm going to rewrite that as my probability of negative ZA p hat minus p over the square root of p 1 minus p over n. Then ZA 1 minus alpha. It's approximate because remember, this is all based on the binomial distribution, and we approximated a normal distribution from the binomial distribution, which is why I'm putting approximates here. All right. So I'm not going to do this last step, but the last step I'm basically going to be saying is I want to take this and do a little bit of algebra, so I'm solving for p by itself here in the middle. So when I do that, I can say that with a confidence level of 1 minus alpha, that my true population is somewhere between p hat minus ZA p hat 1 minus p hat over n hat plus ZA p hat 1 minus p hat over n, where this ZA for a two-sided test is equal to the inverse function of our normal distribution, 1 minus 1/2 alpha. And if ZA, remember, if our alpha is equal to 0.005, which it normally is, that ends up always equaling 1.96. So we don't have to look that up every single time. All right? That's where I got to at the end of our lecture Friday. We picked up with the lecture that we did this morning, this being Monday morning, where I showed you how to come up with the sample size if you're trying to get a particular confidence interval. All right? So this ends our makeup lectures for last week.